Welcome back to my YouTube channel Grandpa Mathematics. Today let us derive the formula for the integrals of these types and solve some problems. We can integrate this by using integration by parts by taking the other function as 1. So we will write 1 into square root of x square minus a square dx. So since it is not possible to integrate square root of x square minus a square, we will integrate 1. If we integrate 1 with respect to x, what will come? X will come. So x into second function. Second function is square root of x square minus a square minus integral of integrated function. Integral of integrated function here is x into differentiation of the other function. This is root x form. If we differentiate root x, what will come? 1 by 2 root x. So if we differentiate this, we will get 1 by 2 times root x square minus a square. But this is not x. So that means we have to differentiate this further. If we differentiate x square minus x square, what will come? 2x minus, if we differentiate a square, a is a constant, if we differentiate 0 will come, into dx. Now this 2 and 2 gets cancelled, so we can write this as x into square root of x square minus a square minus integral x square by square root of x square minus a square dx. In this integral, in the denominator x square minus a square is there, numerator x square is there. So I will write this as x square minus a square plus a square dx. So x square we are writing as x square minus a square because a square is there, minus a square because we have subtracted a square, adding a square. Now if we divide x square minus a square by this term, we will get square root of x square minus a square we will get. So we will write this as x into square root of x square minus a square minus integral x square minus a square by square root of x square minus a square dx. Then minus into plus is minus integral a square by square root of x square minus a square dx. So this gets simplified to x square minus a square minus this in the form of x by root x. X by root x means it will come root x, that is square root of x square minus a square dx minus a square integral dx by square root of x square minus a square. So what is this integral now? This is nothing but I. So we'll take this as I minus a square. What is the value of this integral? X square minus a square log of x plus square root of whatever comes here, that is x square minus a square plus constant. Now, this I you can take to the left hand side, so implies 2I is equal to x into square root of x square minus a square, then minus a square log of x plus square root of x square minus a square plus constant. Now 2I is this value, gives the value of I is equal to what comes now? We have to divide by 2. So x by 2 square root of x square minus a square minus a square by 2 log of x plus square root of x square minus a square plus constant. So this is the answer. So integral square root of a square minus x square dx, again is not possible to integrate. So we'll take 1 into square root of a square minus x square like this. We'll integrate 1. We'll integrate this by integration by parts. So if we integrate 1 with respect to x, we'll get x into second function square root of a square minus x square minus integral of integrated function, that is x into differentiation of the other function. So this will be 1 by 2 times square root of a square minus x square. Again this is not x, so we have to differentiate this further, 0 minus 2x. So it will be minus 2x dx. So we can write this as x into square root of a square minus x square minus into minus plus 2 gets cancelled, then integral x square by square root of a square minus x square dx. Minus into minus plus we return x square by square root of a square minus x square is coming. So denominator a square minus x square is there. So that means we want a minus sign here. How to get a minus sign then? Then here also you have to put a minus sign. So minus of minus x square. Then we want plus a square. So plus a square minus a square dx. So we got here plus x square, because minus x square is there, written minus x square, again change the plus into minus. We want plus a square, added plus a square, so separated a square again. So now we can write this as x square root of a square minus x square minus integral of a square minus x square by square root of a square minus x square dx minus into minus plus a square into dx by square root of a square minus x square. So here we can write x into square root of a square minus x square, a square minus x square by square root of a square minus x square, that is nothing but square root of a square minus x square only, plus a square integral dx by square root of a square minus x square. So we know this is the standard form. Integral dx by square root of a square minus x square is actually, what is the value of this integral? It will be sine inverse x by a. So how to evaluate this integral? This is nothing but I. So for this we can write I. So this implies I is equal to x into square root of a square minus x square minus I, is I only, plus a square. Value of this integral is sine inverse x by e plus constant, plus some other constant. Now take I to the left hand side. So 2I is equal to x into square root of a square minus x square plus a square sine inverse x by a plus constant. This gives the value of I. Just divide by 2, we will get x by 2 into square root of a square minus x square plus a square by 2 sine inverse x by a plus constant. Okay, we have derived the formula. Let us see how to remember these three formulas. First, I will write integral square root of a square minus x square dx. So for this will be x by 2 into square root of a square minus x square plus a square by 2. What is integral of dx by square root of a square minus x square? That is nothing but sine inverse x by a plus constant. Integral, next is square root of a square minus x square, then take a square plus x square. A square plus x square, we can add x square plus a square dx. So this is nothing but x by 2, same x by 2, square root of whatever comes, same term we are writing here, x square plus a square plus again a square by 2. Now what is integral dx by square root of x square plus a square? That is nothing but log of x plus square root of x square plus a square plus constant. So first is a square minus x square, second is a square plus x square, that is x square plus a square. The third one will be x square minus a square dx. X by 2, for this also x by 2 will come, then square root of x square minus a square. Here first 2 plus will come, third minus will come, again a square by 2. This term will be log of x plus square root of x square minus a square plus constant. Integral dx by square root of x square minus a square is log of x plus square root of x square minus a square plus constant. So integral square root of a square minus x square dx is, put x is a sin theta, this becomes a single term. So we remember that sine comes. So a square by 2 sin inverse x by a plus constant. All three formulas, no, x by 2 is there, a square by 2 is there. First plus plus, the third will be minus sign. We have to remember this formula. Now we have to evaluate the integral square root of 4 minus x square dx. So just now we have seen three formulas. So this is in the form of integral a square minus x square form. So we have to write this as integral square root of 2 square minus x square dx. So integral square root of a square minus x square dx. So what is the formula? This is the first one. So x by 2 into square root of 4 minus x square plus a square by 2. What is a? A is 2. A square will be 4. 4 by 2 is 2. So 2 sine inverse of x by a. A is 2 plus constant. So this is the answer. So we have to evaluate this integral. So we can reduce this to the form of integral square root of a square minus x square dx form. So let us see how to do that. We will take 4 outside. When you take 4 outside, the square root that becomes 2 integral square root of, that means we are dividing by 4. So 1 by 4 minus x square dx. So how to check? Take 2 inside the square root 4. 4 into 1 by 4 is 1. 4 into x square is 4x square. So we have to write in the formula form. Integral square root of a square minus x square dx. Then only you can apply the formula. So this will be 1 by 2 whole square minus x square dx. Now this is in the form of integral square root of a square minus x square dx form. In this, if you integrate this, we will get to 2 terms. So I will put a bracket. What is integral square root of a square minus x square dx? X by 2. X by 2 into square root of whatever comes here. That is 1 by 4 minus x square. That's what here, a square minus x square. Then plus a square by 2. What is a? A is 1 by 2. So 1 by 2 whole square by 2 sine inverse of x by a. A is 1 by 2. Plus constant. Now we can simplify this. We'll multiply both terms by 2. So these two get cancels, we'll get x. Then square root of 1 minus 4x square by 4 plus 1 by 2 whole square is 1 by 4, then 2 is there, 1 by 8, but already 2 is there. So it will be 1 by 4 sine inverse 2x plus constant. So this will be, when you take 4 outside the square, that will become 2. So x by 2 square root of 1 minus 4x square plus 1 by 4 times sine inverse of 2x plus constant. So this is one method. Let us see the other method. So to bring this to the formula form, let us take 2x is equal to y. So let 2x is equal to y. If you differentiate with respect to x, we get 2 dx is equal to dy. Therefore, 1 becomes is equal to integral square root of 1 minus 4x square we can write to 2x whole square. 4x square we can write as 2x whole square like that. Then this becomes a y square. Then dx is nothing but dy by 2. So this 2 will take it outside. Now this is in the formula form. Integral square root of a square minus x square form. Then x by 2, that is y by 2, square root of 1 minus y square, plus a square by 2 is 1. So 1 by 2 sine inverse x by a. Here y by a is 1 plus constant. Now we have to replace y in terms of x. So what is y? Y is 2x. Now wherever y is there, we have to put 2x. So 2x by 4, 2x by 4, that is nothing but x by 2, square root of 1 minus y is 2x, so this is 4x square, plus half into half is 1 by 4, sine inverse y is 2x plus constant. So you can do either this method or that method. So in this integral square root of 1 minus 4x minus x square dx is there, minus x square is there. So that means we can write this in the form of a square minus x square form only. So integral square root of 1 minus x square, 1 minus x square, when you take here, it will become plus 4x. Minus x square, minus into plus minus, minus 4x. To write this as a perfect square, a square plus 2ab, 2ab, 2x, 4x by 2x is 2, so plus 2 square minus 4 dx. And square root of 1 minus of minus 4, that is plus 4, so it is 5. 5 we can write as root 5 whole square minus, this will be x plus 2 whole square dx, because the formula is square root of a square minus x square, then only you can apply the formula. Now x plus something we can write it. So what is the formula? X by 2, x plus 2 by 2 into square root of whatever comes here. This is nothing but this we got from here, so I write this one only. 1 minus 4x minus x square plus a square minus x square means plus will come. A square by 2. What is a? A is root 5. Root 5 square. So 5 by 2 sine inverse x is x plus 2 by a root 5 plus constant. So this is the answer. Now let us see how to evaluate this integral. In the denominator we have x into x power n minus 1. So normally if we differentiate x power n, what will come? N into x power n minus 1. So that means we multiply numerator and denominator by x power n minus 1. We'll see what happens. Is equal to x power n minus 1 by x into x power n minus 1 into x power n minus 1 dx. So this will be x power n minus 1 by x power n into x power n minus 1 dx. Now let x power n minus 1 is y or x power n is y. So we'll take x power n is y. Then if we differentiate this with respect to x, we get n into x power n minus 1 dx becomes dy. Therefore, 1 becomes, that is I is equal to integral x power n minus 1 dx. X power n minus 1 dx is dy by n. So, dy by n, x power n we have taken as y, then x power n minus 1, y minus 1. Let 1 by y into y minus 1 using the partial fraction method. So y is there a by y plus b by y minus 1, where a and b are arbitrary constants which we have to find. Multiply throughout by y into y minus 1, we get 1 is equal to a into y minus 1 plus b into y. To get the value of a and b, first to put y is 1, then put y is 0. Y is 0, so minus 1. So minus a is 1, so a is minus 1. Put y is equal to 1, we get 1 is equal to, if we put y is 1, this becomes 0, b into 1. So this gives b is equal to 1. Therefore, this 3 becomes, this n I will take outside, 1 by n integral 1 over y into y minus 1, 1 over y into y minus 1, that is nothing but a by y plus b by y minus 1. So we can write here a is minus 1, so minus 1 by y plus b is 1 by y minus 1. Then this dy comes here. Now we can write this as 1 by n. If we differentiate y, integral dy by y is log y. So this will be minus log y plus log of y minus 1 plus constant. So we can write this 1 by n times log m minus log n. Log m minus log n, that is nothing but log m by n. M is y minus 1 by n plus constant. So this, but what is y? Y is nothing but x power n. So we write 1 by n times log of x power n minus 1 by x power n plus constant. So this is the answer.